that white sheet. All righty. Today we are doing the rest of your gold sheet. So you'll see 3 shapes left. Underneath parallelogram, you'll see 3 shapes. Those are what we're doing. Because they're under parallelogram, they are parallelograms. They're just more specific types. So this first one on the left is called a rectangle. It has 2 new properties. The one on the right is called a rhombus. And the bottom one is a square. I'll go over how to spell rhombus once we get to it. So I'm going to go ahead and do the properties of a parallelogram first, just to remind you. You shouldn't have to write any of this because it should all be on your paper already. Parallelogram has 5 properties. 2 about sides, 2 about angles, 1 about diagonals. Here's what's true about the sides. Opposite sides are parallel. Also, opposite sides are congruent. Same length. Angles. Opposite angles are congruent. And consecutive angles. Who can tell me what consecutive means? Next to. Good. So an angle and one next to it are not equal. They are what we call supplementary. They add to 180. Finally, the diagonals are the diagonals bisect each other. So this long green line is bisected 2 equal parts, and this one was also cut into 2. So the first thing we're going to do is the rectangle. It is a parallelogram. Bless you. Is it a quadrilateral?
Yeah.
Yeah. If you look at your diagram, everything with 4 sides or everything below it is a quadrilateral. So it has these 5 properties. We're not going to redraw the 5. We're going to draw the 2 new ones. One is about angles and one is about diagonals. I know everybody in here knows this top property. Think to yourself what you know about the angles in a rectangle. Yeah, they're all congruent, making them what number? Each angle is 90. Write down 4 right angles.
What do they all add up to?
360. So this section credit. What you do is you do the problem on section paper and you write the property you use. So if you're finding an angle and you use opposite angles congruent, you write down which property for each one. Don't forget to write the property. Yeah, because I've gotten 5 today and none of them did that. So we're going to draw that for right angles. That's easy to remember. And the diagonals. Let's go ahead and draw the diagonals. Going to have you write diagonals are congruent. So I'm going to throw some numbers up here. You don't need to write these numbers. You can just watch for a second. Remember, this rectangle has these properties. So currently we know that these are alike and these are alike. But if I also have this, diagonals are congruent, that means if this whole thing, we'll say is 12, how big is each of these little parts? 6. Now these aren't necessarily 6. They might be 8 and 8, but this says in a rectangle, the diagonals are going to be congruent. So this one is also going to end up being congruent or 12. So how big will each of these pieces have to be? 6. So it's not true up here, but down here, all 4 are alike. So you can go ahead with your pencil. All the little pieces are alike. That's only because it has this parallelogram property and this new property together. That's what happens. Now here's what happens because of that. I'm sure you somewhat remember back when we had isosceles triangles. What happens if I have an isosceles triangle? What else is true? Base angles are congruent. Don't I have an isosceles triangle right here? So wouldn't this angle have to be equal to this one? I would make a note about that somehow. I didn't leave a space for it because it's not a new property. It's just an effect of the properties we have. Your note can say something about how this is isosceles. So this little base angle equals this one. Now let me show you something else. Wouldn't this also be an isosceles triangle? Don't these have two sides in common? Don't they also have vertical angles in common? Wouldn't these be congruent triangles? So if I have, I'm going to make up numbers, don't put them in. Let's say I have 15 degrees, 15 degrees. Well, if these triangles are congruent, wouldn't it be 15 and 15? That's going to happen. It's going to kind of snowball into, oh, I know one angle, I know a bunch of angles. Keep watching. This angle here, this triangle here, this red one is also isosceles. It does not match this one because this angle is different, but it's still isosceles, so it still has two angles that will match up. So if this is, well, I could figure this out, couldn't I? If this is 15 and together they make 90, are you with me? Okay, can we do that in their head? 90 degrees. What is it? 65, I think. So if this is 65, that's going to be 65. And look over here. These red ones, aren't they going to be congruent? They've got two sides in common and this vertical angle in common. So you're going to get a lot of things listed there. Questions on the rectangle, maybe outside of the shape somewhere, you want to name it. Rectangle, this one was from earlier, if you didn't label it already. Parallelogram. And then we have rhombus. What was it? Try not to call it a diamond. That's not really a mathematical term. A rhombus. Let me spell it for you. RHOM. I like to think of a rhombus as like a smushed square. So imagine I have a square. It's like a box or something. I want to recycle it, so I have to smush it. I have to flatten it. So it was a square, nice and even, but now it's kind of tilted or slanted sideways. So the angles are no longer nice and 90 because it's been slanted, but the sides are all the same. And that's your first property for congruent sides. It was a square, but now the angles are sideways, kind of smushed. Four sides congruent, where this had four angles. Two more properties, they're both about diagonals. This property will not be true. This is not a rectangle. This is a parallelogram. So this will still be true. This will be cut in half, and this will be cut in half, but they're not necessarily the same. Diagonals are perpendicular. Write it and draw it. It looks like a kite. A little bit. The kite should definitely be more elongated on one side. A little bit. Remember, this is the perpendicular symbol. I can't tell you that on a quiz. That's perpendicular. So it might say it in words or symbol. Last property, we've never had this before. It sounds confusing, but it's going to be really helpful in finding things. Kind of like this, how things just kept matching up and you got a bunch of answers all at one time. This is going to help you with that. Diagonals bisect angles. Bisect, prefix by 2. So here, a diagonal was bisected, cut into 2. Here, the diagonals are going to cut or bisect an angle. So if I look at this angle, this diagonal is cutting it into 2, which is going to look like this. This little guy equals that little guy. Draw that. The diagonal by 2 equal parts. Convenient for you, these also will be that same number. So I wouldn't write this number, but this is what would happen. If this is 21 degrees, this would be 21, 21, 21, 21. You got 4 answers right away. I wouldn't write 21 because it's not always going to be that number. And also, this diagonal bisects this angle. So these will be a different number, but there's going to be a lot of them. Questions on the rhombus? Or singular plural, you might see rhombi. Same thing. All right. Underneath that, you'll see a square. You can label it square. I don't think you'll forget what it's called. Notice there's no new properties listed. Does that mean a square has no properties? No, that means the square has, because it is down here, that means it has the property of everything above it. It is a parallelogram. It has those 5 properties. It is a rectangle, and it is a square. And we're not going to draw them all in one figure, but they all exist in a square. All righty. Keep that out so we can look at it, please, and get out your white note packet if you would.
Why am I bound to the color? I'm colorblind. Okay, you agree.
We're actually not going to get to all the problems because I've added 2 that I like a little bit better. So we're actually only going to do number 1. And then I'm going to have you draw some other ones. So if you flip to the back, you'll see there's a lot of blank space there. If you would draw this figure, please. So we're on the white note packet. Sort of at the end, there's a lot of blank space. Please draw that rectangle and put the letters where I did. Also write in your notes. Kate is a rectangle. If you look back at this and you don't know what shape it is, you don't know which properties you're allowed to use. Rectangle. Because it's a rectangle, I have these properties and all of those 5. what we're going to do is we're just going to list everything we know about some angles. Can anybody get me started? Any angle in here you know? Which one? So KAT, all of this?
No. T-M.
TM, TAM. So that's the one you're talking about, right? TAM? Okay, so he's talking about angle TAM, which is this one right here. How big is that? 33. Here's how he knew that, I'm guessing. Because we had just talked about in a rectangle that this is true. So he's thinking, okay, so if this is an isosceles triangle, and I've got 33 here, this other base angle has to be 33. Very good. Do we have another one? Anybody else? Yeah.
TMA, I got 14.
TMA. Trace that out. T.
Why did you got it?
Hey. TMA. How big did you say?
114
How did you get that? That's correct.
minus 66.
Very good. Gentlemen. Dupe knows that he has a triangle here. And the three angles in a triangle add up to 180. So he said, okay, well, I've already got 33 and 33. The one reason we have a calculator on our desk today is so we can take 180 degrees minus 33 minus 33. Dupe gave us 114. Very good. I haven't had to help you yet. Any other angles you know? There's a lot missing, but they kind of are alike.
EMK is 114.
EMK, yes. Very good. Those are vertical.
Oh, I gotta know the other two.
Yep. 33 and 33?
Yep.
Yep. Keenan,
KMA is 66.
good. Notice how he labeled it K to M to A. That tells me exactly which angle it. This one. What'd you say?
66.
66. How did you get that?
180.
Good. You're not sure. He's saying this is a straight line. So they add to 180. Is this one also 66?
Yep.
Yep. Once you get started, it just keeps on going. All right, we've got another one to find. How will we find it?
Oh, let me tell you, find it.
Tell me how to find it, please.
Well, you see, with the each angle, without the diagonal.
Right.
Right angle.
Right. So let's pause there. He says this is 90. This whole thing is 90.
Oh, yeah.
And you got 33. So,
90.
33 subtracted from 90 is 57. Is this also 57? Yeah, because it's a rectangle. We have 4 isosceles triangle. Are these also 57? Yes, they are. Now here's how your homework and quizzes will look. It will say, find a bunch of angles. This, just a second. This can be somewhat intimidating. That's why I suggest you always list everything first and then just put your answers here at the end. You had a question on?
Yeah, so when you subtract the 180,
Yeah.
that's 66. So why would you do that to get that?
Because right here we have a straight line. Good question. All right, if you would please copy those 5 angles and then go find them in your picture and write the answer. You've already done the hard work.
What do those numbers say?
Numbers? You have them in your. We have some 57s, some 33s.
Oh, I thought we were filling in the rectangles. I thought we were filling in the rectangles.
Fill them out if you know them. You should.
I don't know that day. I think the one.
I don't even.
Did you miss me? You know what I said when I was thankful for the day? Thankful for Adrian. My kids, yeah.
All right. Let's see how you did in finding them. Remember, just trace about the middle letter is very important. That's your vertex, the pointy part. So T, M, A. Here's T, M, A. 114. T, A, M. T to A to M. Can you tell what angle I'm talking about when I trace it out like that? That's what you need to do. You don't have to always do the full thing, but if it helps you, I can see that that angle is 33. You're not gonna be able to see it, so write it down. MKE. MKE. Also 33. Angle EMT. 66. Lastly, yeah, gentlemen, MET 57. You will see questions like this, as I mentioned, on a quiz, test, homework. Please don't get overwhelmed by the number of things you have to find. You can see this 33 appeared 4 times. The 57 appeared 4 times. Once you get going, you'll probably have all of them fairly quickly. It's better, I think, to do 5 questions regarding this picture than doing 5 new pictures. That's going to make your test a lot longer. You're going to have to reread more directions and look at more figures.
I like to think it.
Thanks. All right, let's try this one. If you would add this one. And make sure you label what it's called, a rhombus. Hopefully you have space there where you're working already. Go ahead and start filling in the angles. You see a 25, maybe there's more 25s. Read your properties. go. It looks like everybody's working. I like that.
Oh, man.
Jackson, can you read me rhombus property number 3, please?
What?
Rhombus property number 3.
Opposite angular parabola?
Rhombus? Not
Yeah,
parallelogram.
I don't even know where rhombus is on my paper, so I.
Diagonal. Here,
So I
Jackson.
just guessed.
Jackson.
Yeah, I didn't write it down.
Okay,
Diagonal bisects angles.
thank you.
Thanks.
Let's use that property. Diagonals bisect angles. So that means this diagonal is
I
cutting
was lost, so I did it.
this angle into 2. So I can already list 25, 25, 25, 25, because it's a rhombus, because the property number 3, diagonal bisects angle. The angle is cut into 2. Now this diagonal is also cutting this angle and this angle. They're not going to be 25, but whatever it is, it's going to repeat. I'm going to have to figure out what number that is. Anybody have a good way of doing that?
Adding 25 and 25 and getting 50.
Yep.
And then subtracting it from 180.
Perfect.
Oh, of course.
Remember, we have a parallelogram. So this angle and the next angle to it add to 180. Consecutive angles. Supplementary. You might think that's not listed under rhombus. A rhombus is a parallelogram. So he's saying if this is 50, this whole thing has to be what? 180 minus 50? 130. What's half of 130 for each of these parts? 65. These will also be 65. Kennedy, can you read me rhombus property number 2?
Diagonals are perpendicular.
That's helpful. Diagonals, perpendicular. So, Kennedy, how big is this angle?
90.
Yeah, perpendicular. That's 90. These are all 90.
How did you do that?
The diagonals are perpendicular. All right, please list out these angles. We can't do this when there's no M.
So if it's perpendicular, it's just 90?
Yeah, that's what perpendicular means, an angle. That's 90. They intersect to form 90. Okay, let's go through these answers. Angle KAS. KAS. That's 25. SLE. SLE. 65. Third one, LSA. Third one is 90. Your last one is KES. KES. 25. I can tell for a lot of us, this is getting easier picking out an angle when it's given 3 letters. Any questions on this one?
I get it now. I took a perpendicular now. I see it.
Good. All right, we're gonna do number 1 from what was printed on your sheet.
Not dumb.
Mine says number 6, but it's number 1. So flip to the front. It should say, given quadrilateral TGIF is a rectangle. I would underline that. If you don't read directions, you don't know which properties to pick from. So I'm looking at my gold sheet and I know it's a rectangle. That's 2 properties, but it's a parallelogram, so it's 5 more properties. So 7 things we can use to solve this problem. Use the properties of a rectangle and the figure at the right to find the following. Let's make sure you're using a pencil because you'll have to draw stuff and erase it for the next problem. Part A. TX is 13. Let's label that. Use your properties to see if you can find TI and FG. I know because it's a parallelogram that the diagonals bisect each other. I also know this. They are all alike. So if I want T to I, and this is 13, this is 13, TI is 26. What is FG?
26.
Yeah. Okay, let's erase anything in your picture so we can draw the next part. Go ahead and label what it says in part B. Can we set those parts equal?
Yeah.
Yeah, because again, this is a property on your gold sheet. And if they are alike, then you can set them equal. All right, I got 9, and that's my answer. It says solve for X. Questions on A or B? All right, erase your picture. We have 1 left. Go ahead and label what it tells you for C. Yeah. Oh, it's on the white paper. The white note. There you go.
I didn't do that. I didn't do that.
Number 1. Are those angles equal?
No,
No, nothing on my goal sheet says they are. They're not vertical angles. They're not alternate here, so no. We're gonna have to use some properties or something else to figure this out. The ideas before I give, yeah,
Would you add them up? Hold on.
not quite. What do you think?
if you add them up to 90,
That is true. How'd you get that?
because that, the top angle is the same as that's
Good, let's look at this triangle. Remember in our rectangle, it's isosceles. So if these are alike, then these base angles are alike. So this one is also 6x minus 4. The more you do rectangles, the more you'll remember this. So it always happens in a rectangle that you have isosceles triangles. So these angles are like, now you can kind of see what he was saying. This angle and this angle, because it's a rectangle, we know this whole thing is 90. So these would have to add up to 90. So let's write that down. These add up to 90. All right, you guys have the rest of your time to work on your homework in your purple packet. Just a heads up that your quiz is going to be Thursday. You'll notice the review is already in your packet if you want to get a head start.
What about this?